Now let's take a look at graphing quadratic inequalities. We're just going to focus on the different steps required to graph quadratic inequalities. To get here, you should have a knowledge of how to graph quadratic equations. If you have any question, there's a lesson that deals with that exclusively. So the first thing we're going to do is we're going to replace the inequality with an equal to sign. So for the sake of that, let's do that right here. X squared minus 9x plus 8. And then we're going to say y equal to that. And we're going to look at the x-intercept, and then we're going to look at the y-intercept. The x-intercept is that x squared minus 9x plus 8 equal to 0, and then y equal to 0. So y is 0 minus 9 times 0, right? 0 squared minus 9 times 0 plus 8. So y equal to 8. Now for this, we're going to factor this. So this is going to give us x minus 1, x minus 8 equal to 0. So x minus 1 equal to 0, x minus 8 equal to 0. So x equal to 1, x equal to 8. So we have x equal to 1 and x equal to 8 for x-intercepts, and y equal to 8 for our y-intercept. So now we have the points, the intercepts. So we have 1 and 8 right here, and then we have 8 for the y-intercept. Now because this is greater than or equal to, we're going to use solid lines to draw the graph of the inequality, the quadratic. So now that we have the graph, what we're going to try is, because we need to find the region that satisfies the inequality, so we're going to use the origin test. So here's what the origin test means. So let's look at the origin test. So what we're going to do is we're going to plug in x equal to 0, y equal to 0 in the inequality and see if the inequality is true. If the inequality is true, every part of the region that has the origin with it becomes the region that satisfies the inequality. But if that is false, then any region that does not have the origin becomes the region that satisfies your inequality. So let's look at this right here. Plug in y equal to 0. So 0 is greater than or equal to 0 minus 0 plus 8. So this here is saying that 0 is greater than equal to 8. This is not true. So this, look at this, everywhere around the graph that satisfies the origin is not going to be true. So it's going to be this region in here that becomes the region that satisfies the inequality. Because if you look at it, everywhere outside the graph has 0, the origin. So these right here, anywhere around here, right around here, outside the graph becomes the region that has 0, 0. So that's how this works. We'll look at a few more examples and it will make some sense after a few tries. So here we're going to first do our equal to here. So y equal to x squared minus 3x minus 10. And so we're going to look at our x-intercept and our y-intercept. Y-intercept is a lot more straightforward here, so let's go for it first. So y is equal to 0 squared minus 3 times 0 minus 10. So y equal to negative 10. Then x squared minus 3x minus 10 equal to 0. So we have x minus 5, x plus 2 equal to 0. X minus 5 is 0. X plus 2 is 0. So x equal to 5, x equal to negative 2. So our x-intercepts are 5 and negative 2. Our y-intercept is negative 10. So now we have our point. We're going to plot our point x. So this is x-intercept, x-intercept, y-intercept. So now our next thing to do is to join the points together with a line. Now we need to figure out if it's going to be a broken line or a solid line. Because we have an equal to in the inequality here, so we're going to have a solid line. The next thing is to use the origin test to figure out our region that satisfies the inequality. So the origin test is 0, 0. So x equal to 0, y equal to 0. So we're saying here 0 less than or equal to 0 minus 10. So here 0 less than equal to negative 10. This is factually inaccurate. So if you look at the area that has the origin right here. So everything outside of that will be the region that satisfies our inequality. So here's how we're going to show it. So this region out here satisfies our inequality. Finally, let's look at this inequality here. First step, y equal to negative x squared plus 5x plus 14. So x-intercept, y-intercept. Y-intercept is y equal to negative 0 squared plus 5 times 0 plus 14. It's going to give us 14 here. And then x-intercept is negative x squared plus 5x plus 14 equal to 0. So negative x squared plus 7x minus 2x plus 14 equal to 0. So negative x minus 7 minus 2 x minus 7 equal to 0. Negative x minus 2 x minus 7 equal to 0. Minus x minus 2 equal to 0. Then x minus 7 equal to 0. So x equal to 2. X equal to 7. X should be equal to negative 2 actually. X is negative 2. Now we're going to figure out the shape of the graph and also what type of line graph it's going to be. Is it going to be a solid line graph or is it going to be a broken line graph? Now this is just a greater than, there's no equal to, so we expect a broken line. And also the coefficient of x squared is negative, so it needs to open downwards. So this is what our graph is going to look like. So this is what our graph looks like. Now we're going to use the origin test to figure out the shaded portion. So origin test. Our origin test is using the point 0, 0, which is the origin. So 0 is greater than negative 0 squared plus 5 times 0 plus 14. 0 is not greater than 14. So the origin does not satisfy our region. Now this is how we're going to show that. Anywhere inside, so the origin is inside the graph, so everywhere outside the graph right here is going to be the region that satisfies our inequality. Now we look at one final example. In this example, we're going to draw another graph right here. And we're going to start off by saying y equal to negative x squared minus 6x plus 16. So x-intercept, y-intercept. So y equal to negative 0 squared minus 6 times 0 plus 16. So y is 16. So we have negative x squared minus 6x plus 16 equal to 0. So negative x squared minus 8x plus 2x plus 16 equal to 0. So we have negative x, we have x plus 8. X plus 8 plus 2, x plus 8 equal to 0. So we have negative x plus 2, and then we have x plus 8 equal to 0. So negative x plus 2 equal to 0, x plus 8 equal to 0, x equal to 2, here x equal to negative 8. So now we're going to plot the point on the graph. So that's this right here, this right here, this right here. And we're going to determine how the graph is going to look and what type of lines we're going to use for the graph. So let's start with the type of line. Because it's a less than without an equal to, we're going to use broken lines. And because the coefficient of x squared is a negative number, our graph is going to be pointing downwards. It's going to open downwards, almost looking like lowercase n to some degree. The next thing we're going to do is we're going to apply the origin test. So we're using the point 0, 0, which is the origin, and so let's sub it in. So 0 is less than negative 0 squared minus 6 times 0 plus 16. So 0 is less than 16. This is a true mathematical statement. So that means that every region that has the origin becomes the region that satisfies the inequality. So that is this right here. We can see the origin in here. So this is our region that satisfies the inequality inside of the graph.